How many adults do you think are fluent in fraction multiplication? In my experience, if you ask an adult who's not a mathematician or a teacher to multiply 1/4 times 2/3, most of them would have a really hard time doing that off the top of their head. Which might make you wonder, is it really important if these successful adults can get by in life without being able to multiply fractions? Should we really worry so much about whether students can do this? And it's a fair question. But a better question is, how can multiplying fractions help us and our students in school and in life out of school? Another good question is, why do so many adults have difficulty with fractions? In this video, I'll explain what it really means to multiply fractions, why it's important to understand fraction multiplication, and how you can ensure that your students develop lasting fluency in multiplying fractions. Finally, I'll show you where to go to find more information and resources that you can use to teach fraction multiplication in your live or online classroom. To gain a conceptual understanding of fraction multiplication, you just really need to know the two component concepts. What is a fraction and what is multiplication? Fractions can either be understood as parts of a whole or as division. The most common way to think about fractions is parts of a whole. Simply, this is the idea that we start with a whole, cut it into pieces, and then we indicate how many pieces we have by the numerator and the number of parts the whole is cut into by the denominator. But it's also important to understand that a fraction can represent division. For example, if we take the expression 3 divided by 5, we can represent that as a fraction. First, think about 3 wholes and then divide each whole into 5 pieces. So if we have 1/5 of each of these wholes, altogether, we have 3/5. To understand the concepts behind multiplication, we need to realize there are actually 5 meanings of multiplication. These are 5 ways that we use multiplication in real-world scenarios. Most of us are familiar with the first meaning, equal groups. The idea here is that we have 2 factors. One represents the size of a group, the other represents the number of groups. The second meaning is a rate. So if we do something like driving 40 miles per hour, in order to find out our total miles, we would multiply the number of miles per hour by the number of hours. The third meaning is area, which we can also think of as measurement of a 2-dimensional space. So when we're measuring a 2-dimensional space, say a room that's 10 feet by 15 feet, we multiply the 2 to measure that 2-dimensional space. The fourth meaning is multiplicative comparison. This is the idea that something can be 3 times as big as, or 1/3 as big as something else. And the fifth meaning is known as a Cartesian product or combinations. This is where if you have 3 different colored shirts and 2 different colored hats, to find the total combinations you can make, you multiply the 3 by the 2. For more on the meanings of multiplication, we have an entire video on our channel called The 5 Meanings of Multiplication. You should watch that if you want some more detail on that concept. So to become fluent in multiplying fractions, we start by thinking about the fraction as a starting value, and then we operate on it using one of those 5 meanings of multiplication. Being able to fluently multiply fractions has tremendous benefits for students in school and out of school. In middle school, the ratio, percent, and proportion standards rely heavily on the idea of fractions. In fact, a percent is really just a fraction out of 100. Fractions are also an important foundation for the concept of slope, which is often taught as rise over run. So this is a fraction representing the change in y divided by the change in x. We often see equations of the form y equals m, the slope, times x. And so here we multiply 1/3 by a particular value for x to find the value for y. The ability to multiply fractions is also an important part of working with algebraic expressions. If students just learn how to perform fraction operations without really understanding those different meanings that we talked about, they're going to really struggle when they get to algebraic expressions like this one. And multiplying fractions isn't just for school. We can use it to find distances. We can also use them in things like recipes. If you need a 1/4 cup of sugar to make a certain cake, what if you wanted to make half as much cake? Or what if you wanted to make twice as much cake? You would multiply those fractions to find out how much you needed. And of course, multiplying fractions has applications to business and money. If you want to grow your wealth by 1/4 over the next few years, or if your business needs to cut costs by 1/3. These are all instances where you would apply what you know about fraction multiplication. So anytime I want my students to develop a conceptual understanding of a mathematical idea, I use an approach that I call the 3 vehicles. The 3 vehicles are scale models, symbols, and stories. And what I've found is that if students can represent a mathematical idea in the form of a scale model, if they can represent it symbolically in number form, equation form, and they can represent it in story form as a real-life scenario, I'm confident that they really understand it. So this can be used as an assessment, but it can also be used as a teaching tool to help students recognize one form and translate into the others. So let's look at a few examples. So when teaching fraction multiplication, I usually like to start with multiplying a fraction by a whole number before moving into multiplying a fraction by a fraction. And in this case, for 1/3 times 2, I would start with the equal groups meaning of multiplication. In this meaning, one factor is the size of each group, and one factor is the number of groups. Now, the important thing is to recognize that these are interchangeable, right? So let's start by thinking about where 1/3 is the size of each group and 2 is the number of groups. So for this example, our group size is 1/3, and we have 2 copies of that 1/3, then my resulting value will be 2/3. This is a scale model because the model represents the size of the number. I can also represent this concept symbolically by recognizing that 1/3 times 2 is 2 copies of 1/3, which is the same as 1/3 plus 1/3, and I know that if I combine 1/3 with another 1/3, I'm going to get 2/3. And I can represent this in story form by saying I ate 1/3 of a cake before lunch and I ate another 1/3 of the cake after lunch. How much of the cake did I eat altogether? Now, I can also think about this the other way, where the size of my group is 2, right? So I start with 2, and then the number of groups is 1/3. And in this case, I'm going to think about fraction as division, that 1/3 of a group means to take one group and divide it into 3 parts. So here I'll take my 2 pieces that I start with, and again, I'm still left with that same result of 2/3. To put this in a real world scenario, I might say that I started with 2 cakes and I ate 1/3 of the total amount of cake that I had. How much did I eat? 2/3 of a cake. Now, when we're multiplying a fraction by a fraction, my favorite way to demonstrate this with a scale model is to use an area model, and this relies on the area meaning of multiplication. So I'll start with a rectangle, cut it into 3 equal pieces, and to demonstrate 2/3, I'll shade in 2 of those pieces. So this represents 2/3 of the rectangle, and I can also think about this as a length of 2/3, where the whole side would be 1. Next, I'm going to cut the other direction into fourths, and I'm going to shade in 1/4. So now I have 2/3 going down, 1/4 going across, and to find the area 2/3 by 1/4, I look for the overlap. 2/3 of 1/4, or 1/4 of 2/3. So 2 of these boxes are shaded in both colors. So that's my numerator. And to find my denominator, I count the total boxes after I've made all my cuts, which is 12. I can also simplify by pairing all the boxes. So instead of 12 boxes, now I have 6. Instead of 2 colored in, I have 1. So in simplified form, this comes out to 1/6. Now, using an area model like this is also a great way to lead into the traditional algorithm for multiplying fractions. If you remember, in the traditional algorithm, we will multiply across the top, 2 times 1, and we'll multiply across the bottom, 3 times 4, to get our result of 2/12 or 1/6. Now, the reason that works, we can see this very clearly. When we had 4 boxes down and 3 boxes across, we multiplied 3 by 4 to get our total boxes, and we multiplied our 2 boxes across by our 1 box down to get our total of 2. And finally, to put this into a story form, I could say that I drink 2/3 of a liter of water every mile that I walk. If I walked 1/4 of a mile, how much water did I drink? And that would still be the same response. I would drink 1/6 of a liter. So I hope this video has helped you to take a conceptual approach to fraction multiplication. If so, please hit like and subscribe to our channel. If you're interested in learning specific strategies to help you bring conceptual learning to your math classroom using the 3 vehicles approach, you'll want to sign up for one of our upcoming workshops. We offer workshops for a range of grade levels, and each of our math workshops incorporates some form of the 3 vehicles. Finally, if you would like complete lessons that include lesson plans, digital interactive activities, keys, rubrics, you'll find all of those on our Teachers Pay Teachers store, roomtodiscover.com/TPT. Thank you for watching, and thank you for giving your students room to discover.